Hi everyone, welcome. This week we'll be looking at object-oriented programming concepts. I always like to look at why we need yet another tool in our toolbox. So I want to give you a little rundown of the background. So what I'm going to do is use my whiteboard just to demonstrate some thoughts. So let us assume that I have 3 cats and 2 dogs. Okay, so I have and 2 dogs. And I want to think about if I were to document this somewhere, or if I have a rescue or a shelter of some sort, I might want to document the information about my cats and dogs. So what kind of information would I care about a cat? If I am in a rescue or in some kind of organization, usually the cat will have a name, the cat will have an ID tag, and then the cat, what else can, age, the age of the cat, right? These seem to be important information that we will document. And then we might have vaccination history. Then we might have any kind of a health conditions. Then we might even before this, maybe there's a couple things we can add, like color of eye, type of cat. Maybe there are different varieties, the domestic, short hair, long hair, whatever it is, right? So something like that. Let's look at our dog. The dog again will have a name, so there'll be an ID. Age of the dog is important. I don't know, color of the dog, not color of eye, color of the dog is important. Then the dog breed. So maybe this is what I meant here. So pretty much similar kind of information is what we need. Right, identical in this situation at least. So it's very, very similar in the kind of information we want. So where it is different is, so these define what a cat is, right? We could have a cat called Snowball. We could have a cat called Tiger. Tiger will be probably an orange kitty with stripes on it. Snowball probably is a long hair fluffy cat. And then maybe one is a ragdoll type, one is a domestic long hair, whatever it is. Again, we can have 2 dogs, one is a pug, one is a beagle, right? Age, one is a puppy, one is a senior. So all kinds of things. So those are the features of the dog or cat. These what I have listed here. Other than this, in terms of characteristics, a cat will purr, play. What else does a cat do? It'll eat, it'll sleep. These are some of the actions associated with a cat. A dog will not purr, right? A dog will bark, play, eat, sleep. What does the dog eat? Dog food. What does the cat eat? Cat food. They probably have their own levels of allergies and toxic food and all that. So let us think about this and see how we can implement it. Okay, oh, one more thing, play. More than play, I just want to say fetch. So a fetch is a very unique thing for a dog. A purr is a very unique thing for a cat. Again, bark is unique for a dog. It doesn't apply to the cat. So that is where we start seeing variations. Okay, so if I were to write this in code, so here's what, just to save time, I've written it. So what I have here is I have a program called week 5 cat and dog. I hope you can see better now. So I have week 5 cat and dog. That's my program name in my Repl. So this is the code. So when I think like I have 3 dogs and 2 cats, and then I want to know cat separately from dog, right? We just want to like, don't want to combine all the animals together. So I created 3 arrays to hold. I just picked, like, I didn't want to like do all of them. So I just like picked a few from here: name, age, ID. So I just want to like collect this information, nothing else. Okay, for now. And then I want to do the purr, the bark, and the fetch. So that's all I'm going to write code as. So I have the array for the cat. Then I have an array for the dog. Just to know which one is which, I made the cat array to start with a C underscore and dog array to start with a D underscore. So I'm getting information for a cat by using the loop. Then I'm getting information for the dog using a loop. Then I'm saying fetch. I'm giving the name of the dog. I'm calling a method called fetch. Okay, and then I'm calling a purr method for a cat, bark for a dog. Okay, oops, call, not cat. Okay, this method we have seen already, right? Arrays we have seen already, methods I've seen already. So what does the method do? It is just a void method. It returns nothing. It just writes, whenever I call it with the name of the cat, it would just say, yeah, I love ball. Okay, and then let's add. I just want to know which one said what. Okay. So what is the point of this whole thing? I will explain in a second. So, oh, okay. In 32, what did I do? Two. I forgot 2. Okay, now let's run it. Okay, so hello world, enter cat info, enter name. So I'm going to call Snowball, ID 1111, age 2 years old. Again for the cat, Tiger, ID is 2222, age is 5. Third cat will be Jingle, ID is going to be 3333. Age is going to be 3. Now dog. So dog information. Enter the name of the dog, Spotty. ID will be probably 1234. Age is going to be 6. Another dog name is Snoopy. Oh, what did I do? So here's the thing. Yeah, I love ball. Spotty says I love ball. Purr says leave me alone. And I'll tell you why this errored. It should be 1, not 2. Okay. So here's the thing. When I called fetch for the dog, it said, yeah, I love the ball. And then the name of the dog displays. When I say purr, it says purr, leave me alone. That name of the tiger, the cat displays. Third one I got an exception because I had it as 2 instead of 1. So don't worry about it. So the point I'm trying to make is we are trying to use the tools we already have. We have arrays to capture collection, and then we have methods to make a call to make this cat or dog do something, right? We just want to like write a method. So you can keep writing for eat, sleep, and then it can give a message and all that. But here is where the problem is. So I can not only make a dog bark, I can also make a cat bark. So there is nothing stopping my cat from barking. If a programmer decides to like make a call like that, he can make a cat bark. Okay, because what is inside this cat method? the bark method, nothing. You just like take this information and then just say bark. Okay, it'll say bark, 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 wag tail, whatever. So, so maybe we need to add some code to stop it from working for a cat. So how do we make it stop working for a cat, or how do we make the bark only work for a dog? What information do we have that tells us it's a dog? Nothing. There is nothing we collect that tells us it's a dog. Okay, we know the name of the array starts with a D. That is not something we can use. Okay, other than that, see, these are strings, integers. These are strings, integers. Nothing is different. Okay, let us say for the dog, the numbers start with a D underscore for the ID. There is nothing, no way we can do that either. So you can't like separate or identify this information for a cat and this information as information for a dog. You can control what methods get called, because you can think that, oh, I just wouldn't call it here. I know. But here is the thing. It can be dependent on who is writing the program. There should be some checks and balances in the code that stops people from making these kind of invalid method calls. Okay. If so that is the limitation of this particular approach, which is why we go for object-oriented programming. Okay, all the things that we saw so far work perfectly fine because of the kind of data we were using. But right now we are trying to think about, oh, in the real life, in the real world, we have a dog, a cat, a dinosaur, a dragon, whatever it is, right? It could be a scissor, it could be a cooker, it could be a stove, it could be a printer. These are objects and they are complex. A printer not only has a printer serial number, it has a make, it has a model, right? Let's use an easier example, a car, right? If you have a car, you have like a year, make, model, your VIN number, the year that you purchased the car, the dealer you got it from, whether you have a loan on it or not, it's called as the lien on your car or not. And then also the mileage on the car, whether it had accidents, is it a lemon? So there is so much information that we want to capture if we were to use just an object, right? I gave a simple example of an object. Just to like think about another example, employee, that we have been using. We used an array for salary, we used an array for bonus, but think about the real life of an employee. An employee has name, identification number, the company he works for, his date of joining, his current performance records from God knows whenever he joined, his title, his current salary, every year the promotion, whenever he received promotion, all those dates. So it's very complicated. Okay, the last 4 weeks, all the data that we saw is very simple. Okay, we are looking at really simple. We are looking at one little piece of attribute, and then we were working towards it. We just took like the name or the age or one of those attributes. Attribute is just a feature, and then we were working with it. Now when you look at it as a whole, as a cat or a dog, it's much more complicated. All these things define a cat, and all of these are actions done by a cat. So all these are attributes of a dog, and all these are going to be actions performed by a dog. And we are not like doing all of it. I'm just giving you a sample here. Okay, so you have to like start thinking about features. Ooh. So features, and then you have to think about the actions that these characters can perform. So these are actions and these are features. With the toolbox we have so far, we cannot accomplish a very seamless we cannot write seamless code that would prevent the cat from barking or a dog from purring. They can all play, eat, and sleep, but what they eat is different. You know, how long they sleep is different probably, and what kind of play they will be interested in is different. Cat wants a yarn, dog wants to fetch a bone. So that is where the differences come in. So when you're looking at an object, when I say an object, what we mean by that is, this is an object. So in the real, in like a layman's term, when I say object, I mean things that are tangible in the real world. So they are not like the holistically, the wholesome, a cat with all of its features and actions can be thought of as a real life object. Okay, so we could have a cat called Tiger. Let me go write it. So the three objects that we wrote. So we have three cats, okay? We have Snowbell, Tiger, and Jingle, right? So Snowbell is 2 years old, and it's a white cat with long fur. Tiger is striped, it's 7 years old maybe. And then Jingle is going to be like 3 years old and it's completely black. Okay, let's assume that that's the case. So Snowbell is an object, Tiger is an object, Jingle is an object. But cat, on the other hand, is a blueprint. When we say cat, there is nothing called cat in real world. It exists only in our book. Okay, it is a blueprint for an animal with certain traits. Okay, however, Snowbell, Tiger, and Jingle exist in the real world. They all belong to this species or a feline species, cat being the subspecies or whatever it is. Okay, so that is what I want you to think of. This blueprint, and these are real world animals that exist in flesh and blood. Again, if we have Snoopy and Spotty or whatever call them, so if we have like dogs here called, my dog's name Debo, and then we call Jimmy, whatever the names are, the dog names. Again, these are the concrete implementations of this particular blueprint. Okay, we have Debo and Jimmy are the two dogs. Dog itself, there is no such thing as dog. We could have stray dog, but still if you were to like identify the stray dogs, again, their age and color and breed and vaccination history and health conditions, all of them will be different. So there is no such thing as a dog in the real world. We have animals that belong to a species, a specific species that share the same characteristics. So keep that in mind. So we have these are our actual pets and they have all these characteristics that are common. So the commonality is termed as cat or dog. And this particular cat or dog species can perform certain set of actions and they have certain set of features. Okay. So if we were to go to a brand new page, the blueprint that we talked about is called as a class. Okay, and then every single implementation of the cat class is called as object 1, object 2, object 3, so on and so forth. So this is called as object-oriented programming. In object-oriented programming, we are not just thinking about like one slice of something, but we are looking at it as a holistic, complete object. We are not just looking at the name or the age or whatever. We are looking at it holistically, so we can define that object in its entirety. Okay, so this would be Snowbell, this would be Tiger, and this would be Jingle. Okay, so class is cat, Cat is a class, and then the objects are going to be Snowball, Jingle, and whatever the other one, Tiger. Okay, so and then a class, when you are to create a class would have features and actions. So if we were to like talk about it in the terminology in C#, it will be properties and methods. A class would have properties and methods. Okay, properties are going to be the features, methods are going to be the actions. Okay, so there is also one more variation called as field. Okay, so and I will like explain to you what field versus property is as we go along. But for now, think about it. The properties and so I will let me put a line here like so. So this is going to be the features and this is going to be the action. So when you say the per, eat, sleep, so this is going to go to methods. And then the rest of the things that we saw about the name, ID, age will go into field. Okay, so just remember that a class is a blueprint. It doesn't actually exist. Only objects exist. These objects will say that they are from this particular class. So Snowball is a cat. This object 1 belongs to this class. Okay, and then a class, when you define the blueprint, you will have to define the features and actions. Okay, the features can be properties or fields, and they can be properties, fields and properties, and then actions will be methods. I want you to start thinking about other real life things that could translate into an object-oriented programming class that you can write code for. Okay, so I will see you in the next video where we will expand more upon this. Thank you.